Continuing on in Chapter 9, we are looking at the alkylation of terminal alkynes. Now, this is a really important reaction as we move into synthesis, because this is the first reaction you learn, aside from maybe making a new nitrile. This is one of the first reactions where you make a new carbon bond, and carbon-carbon bond. And as organic chemists, we are interested in studying compounds made out of carbon, right? And so ultimately, we want to build new molecules with carbon backbones. And so having ways to put carbons together is really important. Now, we covered this earlier, that the terminal alkyne is a bit special because that is a much more acidic hydrogen on a carbon than what we usually see. If we have a strong enough base, something like sodium amide, we can actually deprotonate. Now, this is a very strong nucleophile, right? This is going to be very reactive. Carbon doesn't love to have a negative charge on it. So if we use this as a nucleophile in an SN2 reaction, for instance, we can make a new carbon-carbon bond, right? So we can take this alkynide or acetylide ion, right, the triple bond carbon with the negative charge and a lone pair, and we can use some sort of alkyl halide, right? Remember, your SN2 is going to be a nucleophilic attack and loss of leaving group. This is going to leave us, and let's make that like R prime, because the R groups don't have to match. That's going to leave us still with our triple bond, but now a new carbon-carbon bond out to R prime. This is going to give us a lot of synthetic utility to make larger molecules. You know, Breeze has to say hello when we get to talking about organic. All right, so if you look at this slide, you can see how this might be presented as a multi-step reaction. You start off with your terminal alkyne. You have the first step where you are deprotonating, and then you're adding in some sort of alkyl halide. Now, if this is going to be an SN2 reaction, there are going to be some limitations on what you can use as your alkyl halide. I don't plan on trying to trick you with that, right? I won't give you a tertiary substituent. What's also nice about this is if you start off with acetylene, right, IUPAC ethyne, you can actually add to both sides, right? We could set this up where in one step, you remove one of the hydrogens. And when you do this, it is only going to remove one hydrogen. You are not going to make a negative charge on both carbons at the same time. So if you want to add to the left and the right, you have to do it in two different steps. So we'll remove one of the protons, and then we'll add whatever R group we want. We want to be thoughtful and count right here when we make something new. So let's say we're going to add that to the right. We still have the two carbons from the alkyne. This has 1, 2, 3, 4. So we would have 1, 2, 3, 4. Now from there, you could continue this little party. Since we still have a terminal alkyne, we can deprotonate using sodium amide. And then we could add something totally different on the other side, right? Maybe on the other side, we just want a methyl group. And we could use iodide. That's a great leaving group. You can use bromine. You could use chlorine. Don't use fluorine. Fluorine is not a good leaving group, right? And that would put a methyl group on the left side. Keep in mind that this reaction is going to leave that triple bond. So if you don't want the triple bond in the end, you have ways you could get rid of it, right? And this is just how that is summarized. This is a specific, using an ethyl and a methyl. These are abbreviations that you should recognize ET stands for a CH3CH2 group or ethyl. ME is a CH3 or methyl. Very common abbreviations. What's nice about this is you wind up with something. So let's say I had 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2. And then here. Now I can reduce this. I can hydrate it. I can put on halogens. I can make ketones. I can put in a double bond, and then I have all the access from the double bond. That triple bond is kind of a fun functional group that gives us a lot of options. If we were just trying to make an alkane, well, then we could just use hydrogen and platinum. Now, at the end of each chapter, you're going to see synthesis strategies. We're going to get a full chapter on synthesis in chapter 11, but it is important that you start reading these now. Synthesis is a big kind of burly topic, and the more you practice these small little increments that you're getting up in chapter 8 and 9, the easier chapter 11 will be for you. All right, all the synthetic strategies that you're seeing right now are just showing you how you can connect functional groups. Right? If you're trying to get from an alkene to an alkyne, and you may need to do that for some reason, you're going to brominate, and then you're going to reduce. Right? So there is no straight shot one reaction to get from double to triple bond, but there are ways to do it. And so that's going to be part of your job, is putting together reactions. Moving between triple, double, and single bonds, you have lots of options now. If you are not somebody that reads the bulk of the text, Klein does a really excellent job at these summary slides and with summary pages in the book. So I definitely recommend giving those a pass over. This is just a list of all the reactions we've gone over. Some you have to know the mechanisms for. All you have to be able to predict products. A stamp of that. Here is just an overview of all the reactions we saw. I did put a spider diagram on eCampus for you, just like for the alkenes. But you could always use this slide instead. And that is the end of chapter 9. Hopefully at this point,